How's it going, everybody? Good. Got a small little class, that's good. This is a new one that we've got, so I'm gonna have to kind of wing it. We didn't do this last year, so I guess I'm really anticipating everybody in here has just got single beam, or they just got a multi-beam, or thinking about getting a multi-beam and kind of on the fence. Does everybody in here have multi-beam, single beam? Which one do you have? Single beam? Everybody has single beam.
I'm not familiar with how to use it.
Is that right?
Yeah, I'm sure.
And who's got multi-beam? A couple people have multi-beam. Who's got a multi-beam but doesn't know how to use it? That's you. Yeah. What company are you with?
Coastal Frontiers.
Coastal Frontiers? Okay. So this is probably going to be a shorter class because, you know, just the difference between single beam and multi-beam. And I'll go through the program too. There's not a whole heck of a lot of PowerPoints, and I'm not a huge PowerPoint guy. I'd rather just go through the software and kind of show you, where the buttons are, because I think when you go back out into the field, that's what you're going to need to know. So we'll go ahead and get started. So moving on up. Okay. So when we talk about the difference between multi-beam and single beam, you just get more coverage. I mean, come on, everybody knows that, right? You get a wider swath. Okay. So this is just showing the sonification area, single beam versus multi-beam. Okay. So depending on the specification of your sonar and the swath width that it's rated at is what you're going to get in total swath width. Is that total swath width good data? No, not always. So if they say that the sonar is good for, 200 degrees or 180 degrees or 160 degrees, really the good stuff is inside of 65 degrees port and starboard, right? It's something, a consideration that you'll have to make is running these performance tests that HYPACK has to see what your standard deviation is based on your angle, your beam angle. So typically the outer beams are less accurate than, say, your nadir beam, the vertical most beam. Okay? And with single beam, it's really kind of like your nadir beam. It's just a straight down sonification with a footprint size of whatever transducer beam width that you have. Typically, what do we see for beam widths for single beams?
3 degrees.
3.8. What about low frequency?
Oh.
10, 12, much wider beam. Okay. So depending on if you have high or low frequency, kind of will dictate what your beam width is going to be. Okay. So same thing goes for multi-beam. Each array or each ping on the bottom has a footprint size, just like a single beam. So it's a lot of single beams into one head. Okay. Started off with the older sonars that I started using in the field years ago. Had 16, and then 24, and then 64. Now it's 256 and 512 beams. So the more this stuff evolves, the more beams you're getting into a smaller sonar multi-beam head. Okay, and that's what this talks about, is the sonification area. Okay, this is the footprint size of an 8 degree. It's 7 feet and 50 feet of water. Okay, you have 3 degrees, 50 feet, and then you have 1.5 degrees. 1.5 degrees is starting to get to a really high, you're starting to get into a more higher end multi-beam system. The smaller the beam width, the tighter the sonification, the more area you're covering with your pings. Okay? Because based on how sonar works, you're either getting, with single beam, the first return inside of the sonified area, or in multi-beam, you're getting the strongest return. Okay? So this is pretty important. Know what kind of footprint size or what your multi-beam is rated for. Okay? And then we have a 0.5 degree by 1 degree sonified area. So you can see that exponentially, we have more footprints inside of the overall 8 degree and 50 feet of water. So when a multi-beam manufacturer is telling you about the beam width, the beam spacing, this is the number that you're going to want to look for. You know, is it a 3 degree, 1.5 degree, or a 1/2 by 1 degree? Okay, and that'll be on all of their spec sheets. Okay, and usually when you look at price, cheap, more expensive, gets more expensive. So this seems to drive the price. I may be wrong. I'm not a salesperson. I just kind of know how this stuff works and how the software handles it. But typically that's what drives the price, is the beam width. Okay. This is just showing the data collection differences. We can paint the matrix with single beam data. If you make a matrix around your survey area, you can use the Sonar for matrix updates. With multi-beam, you're painting the matrix full swath. Okay? You don't have to display the full swath updating the matrix. I recommend when you're doing HYSWEEP surveying, just to make sure that when you're done surveying, you have good overlap. Don't overlap the total capacity or the total swath width at 50% coverage. Paint the matrix where you're 65 degrees and in port and starboard and overlap those beams. That way when you get back into the office, you know that you have good overlap, 65 degrees and in. Does that make sense? So I guess what I'm saying is if this multi-beam right here is 200 degrees total, we know that everything inside 65 degrees is good. What we want to do is we want to cut off, in the HYSWEEP program, we want to cut off these outermost beams to update this matrix for coverage, so that when we do our editing, when we clip it to 65 degrees, we don't have gaps in between the run lines. Okay? So those are some things that I can show you on the data collection side.
Is when you're with the multi-beam, is it really depend on the depth of water that you're using, your overlap?
Yes.
It's like, you know, with side scan, you know, you try to get 50 or more feet of overlap inside your, say like when you put your plan lines in.
Yep.
So say if you're running 50-foot plan lines, should you, when you're with multi-beam, should it be based on your water depth to get the coverage, or should you just kind of run the 50-foot plan lines?
That is a great question. So there's two ways to approach it. There's a good way and a better way. A good way is to kind of have a good idea what water depth is to make a decision on how to make the plan lines so that you get the overlapping coverage of 65 or 70 degrees. The other way is to make one plan line and then let the HYPACK driver auto lines make your next planned line based on the water depth for your next adjacent run line. And that's an option in HYPACK. So that you don't have to, it takes the guesswork completely out of it.
Because a lot of berths, you know, when you're up against a berth and you're running parallel with the berth, you're in 30 feet of water and you can go out to 60.
Right.
You know, so that's just the way, I mean, I'm new to this multi-beam, you know.
Right. So the program will see that the swath has measured a 60-foot depth. So it will actually make that line farther apart in that one particular area because it's going to be a multi-segmented line. So now it's going to separate the lines a little bit more because you're getting a wider swath width because you're in deeper water.
Can you set that, the auto lining, can you set it to a 65 or however beam width?
Yeah, I'll show you the driver and how it works and where to add it. I'm going to try to cruise through these PowerPoints and kind of show you the buttons and some of the basic drivers that we have. Okay, so an advantage is you can survey under stuff. You can survey under barges or ships. So if you can't get the boat in there, it's got a swath width So you can see underneath objects. And everybody kind of probably knew that already. This is just saying that single beam can take one measurement at a time, single beam. The multi-beam, many pings per second. Okay. The beam characteristics, this is a good slide that will show you the beam width and the depth of the water and the footprint size of the beam on the seafloor. So an 8-degree transducer beam width in 40 feet of water has a 5-foot footprint on the bottom. 3 degrees in 40 feet, it's less than half. So it's a 2-foot footprint on the bottom. Okay, these are the different types of multi-beam sonars that are out there. They're beam forming or interferometric. The beam forming uses the amplitude and the interferometric uses phase detection. I guess the only really thing that I can say about that is that interferometric systems are, I guess, relatively new to hydrographic, to our world. And from what I understand, side scan manufacturers have gotten into bathymetry with their sonars with the interferometric technology. They've turned a side scan into a multi-beam with the interferometric stuff. So, does it pass IHO standards or USACE hard or soft bottom standards? I don't know. You have to do a performance test on that stuff. But both are really nice. Usually these beam forming systems, Odom and Norbit have beam forming systems. Down here with interferometric systems, you're talking about like an Edge Tech, like a 6205 or an OEM 2205. Okay? Just slightly different technology on how it digitizes the depth. Okay. HYPACK does in the editor ray tracing. So we collect a sound velocity profile through the water column. And we'd like to do it in many different spots around your survey area, different times during your survey, depending on if you have tide. And what we do is we map out the sound velocity through the water column and we ray trace. So the launch angle of the ping, if we didn't consider sound velocity, would be this point down here. But with applying the sound velocity, now we can move the sounding to the right position based on the sound velocity file and ray trace and reposition the sounding where it needs to be. Okay. Sound velocity corrections, it's a table. It's depth versus sound velocity. Most of these probes, this one here, this is a Castaway that YSI sells, and it does a couple of different things. I think all the sound velocity probes are really doing this now. They have GPS embedded inside of them, and obviously they have a timestamp, because they've got a position and a timestamp, and it's also collecting the sound velocity at depth. So if we know all of that stuff, we can apply the right sound velocity value at the position where the ping occurred, or close to it. And these files that come out of these sound velocity probes can be a direct import into our sound velocity program. So this particular one here, I think the AML does something real similar to this one here, this Castaway, but it's a Bluetooth connection between the computer and the probe, and it automatically just uploads the data into our table, and then you can save that out as an SVP file, sound velocity profile file. And that sound velocity profile gets loaded into MBMax 64. So if you have, you're surveying out here in Jax, and while you're surveying, the tide has gone out, and then it's come back in, and then there's a river discharge coming in somewhere, you're going to want to take several sound velocities during the different phases of the tide throughout the day, and different sound velocity casts where the freshwater discharge is entering inside of the channel. That way you can get a real good idea of how the sound velocity changes over the footprint size of your project. Okay? and the MBMAX 64 program will kind of look at all those sound velocities and make the right decision on which one to apply. Okay, so if you do not have sound velocity, that can be a big issue. A lot of people say, oh, can I survey without sound velocity? Sure. If the sound velocity doesn't change throughout the water column. We have a lot of people up on the Mississippi River that survey in 20 or 30 feet of water, and they've been surveying this area forever, and the sound velocity doesn't change much throughout the water column. And it's not a problem not having a sound velocity. We have other people that are in Louisiana, and in the summertime, it's fresh water, and they think they don't need a sound velocity, but what they're not thinking about is in the south, in the summertime, the top of the water column gets real warm, and then underneath that, there's a thermocline where it gets cooler. So in that case, even though it's fresh water, you have to go ahead and do a sound velocity to map that thermocline. And because if you don't apply the sound velocity, you're going to get something like this. You're going to get a smiley face or a frown in the profile window in MBMAX. And right off the bat, when you see that curve in the data, you're going to know immediately it's a sound velocity issue. Okay? And it will always cause it on the outermost beam. Near nadir, it won't show up as much. So if you want to see if sound velocity has been applied properly, go ahead and display the full swath width in MBMAX 64 and look to see if you've got any of these smiley faces. And when you have one pass versus another and they're overlaid, you're going to see two smiley faces right next to each other. And it's going to look real goofy. Okay, so that's some of the corrections. Sound velocity being one of the most important is where do I mount my multibeam? Where would I mount my multibeam? Well, if I had a boat, I'd cut a big hole in the stern working deck and put a moon pool in it with an electric winch so that it went down to the same spot every time with a stop. And that would take care of my measurement of the draft. And I would make sure that it's got a couple of really nice connection points where it doesn't vibrate during the survey. Because what we see, it's an environmental issue that we always are talking about with our customers, is when the boat is underway and the sonar is over the side or over the bow, it can be vibrating if you don't have 2 or 3 points of contact of the pole to the boat. So we always recommend, if it's an over the side, there's an arm that's attached to the boat. We want another connection point to sure up the vibration to make sure that that pole doesn't vibrate. Because what will happen is you'll see that vibration in the data and it's really hard to get rid of. Okay? Because the way that multibeam works is it's got a transmitter and receiver and it's expecting the stuff to go out at a certain time in a position and to receive it back so that it can map out the slant, range, and angle to get a good position of the sound. Well, if that vibrates, things are out a centimeter or 2 centimeters, that throws the whole thing out. So you're going to see artifacts in your data. I'm just ranting about that, but where do I mount it? Mount it in a good place where it's nice and sturdy. And if you can, make sure it's a place where you can somewhat measure it easily to the center of gravity on the boat. Does anybody have a really big boat? Okay. You have a really big boat?
Yeah.
How far is your sonar from the center of gravity of your boat?
We use a pole rod because the wood mount one is out of the nerve. It's well, towards the side it's 13 meters to the port side, and vertically it's about 6 meters.
Okay.
Yeah.
It says locate your boat's center of gravity. And I'm gonna stop here. I'm gonna talk about this because this is really important because this affects the quality of our data. Is being able to know where the sonar is relative to that COG. All of our lever arms are computed from the center of the boat being 0, 0. So that means pitch, roll, RTK, antenna height, and sonar draft are all derived and computed based off the pivot point of the boat at the water line. Okay? So everything in HYPACK as far as offsets go goes to the COG and to the water line. Okay? And it's not showing the water line here, but you don't have to be precise with the center of gravity. So you've got a big boat. You might be able to talk to the naval architect that designed that boat, and he'll give you a pretty good idea of where that COG is. If you're on an Armstrong boat or a Scully boat or Parker or something like that, sometimes you just got to go out there and walk around and go, this is pretty much the center of the boat. Okay? So that the lever arm corrections are computed properly and we get a good position on the sonar on the bottom. So people ask us all the time, can I just offset everything to my sonar? Well, you can if the RTK antenna is on the same pole and the MRU, the heave sensor is on the same pole. However, the takeoff angles are more accurately computed when everything is offset to the center of the boat, because that's the way our programmer wrote the program. Okay, so very important thing. So sound velocity and finding the COG of the boat for your offsets. Okay, how would CG be dynamic? Fuel, load,
Fuel, water,
more people on a small boat.
waves.
Yep. So it's almost impossible to find out exactly where it is. Just try to get as close as possible.
Good question. Is it the center of gravity or center of buoyancy? Because sometimes some places it refers to the center of buoyancy. There's no center. It depends.
Yeah. I'm not sure.
I'm using the center of gravity, but
We'll call it the
I
fulcrum.
have seen some
Yeah.
documents center
Yeah.
of buoyancy because
It's the center of rotation.
yeah, that is the point where the ship is subject to 6 degrees of freedom.
Okay.
It's not always the center of gravity, but like a general rule, everybody is using the center of gravity.
Right.
I do too.
Okay. So installing your multi-beam, mount your motion sensor, MRU or IMU at the CG or as close as possible. Who's got a pause MV in here? Okay. Who hasn't heard of a pause MV? Okay. So a pause MV, generally speaking, it comes with an IMU, which is a small little box that has all the internals that does the pitch and the roll and the heave. Okay. It's got a little bullseye on it. Okay. That's the reference point to measure all of your offsets for the 2 antennas that come with that pause MV and need to be measured to that IMU. So in the pause MV pause view program that comes with that IMU, you need to define where that primary GPS antenna is relative to that IMU. The closer that you can get your antennas to that IMU and that IMU to the center of gravity, the easier it's going to be for you to measure the offsets accurately and for the lever arms to be computed very accurately at the center of rotation of the boat. Does it have to be at the center of the boat? No. Sometimes it's impractical to get that IMU at the center of the boat, but the closer the better. I think I already mentioned mount as rigid as possible. So order of preference, hull mount, moon pool, pole mount, or over the side. Okay. Everybody knows get your antenna up as high as possible, and heading is really important as well. But if you have a pause MV, it does a pretty good job resolving heading to 2/100ths of a degree, and that will be seen in your pause view program real time. You can see your residuals and you can see what your error is for heading and position. All right. So, you know, when we start talking about doing patch tests and calibrating the multi-beam with our patch test routine, having good satellite geometry, very accurate RTK, and heading accuracy, having all of those things as tight as possible is going to give you a better patch test, which is going to in turn give you a better surface from your multi-beam system. So imagine if your heading is out a half a degree and you're in 50 feet of water, a half a degree with a 50-foot lever arm, you're going to be very far off on the seafloor, especially when we talk about coming back on a reciprocal pass and trying to match up depths. Those depths aren't going to be in the same spot. It's not going to be the same elevation. Okay? Okay, so the next thing that's real important for multi-beam is clock synchronization. Now, this is something that, this is probably the most important thing for multi-beam. This is probably something that we get the most calls on as far as multi-beam goes. If people are seeing artifacts in their data or just not seeing their data at all, it's probably because there's a timing issue. There's either a software setting that hasn't been set correctly, or there's a hardware consideration that the customer didn't use. So the first thing that I kind of do when I get on the boat is I kind of look at what equipment's being used, the positioning device, the heading device, and the sonar, check out the offsets and make sure that I can look around the boat and just generally see where everything is located, and then look at HYPACK hardware to make sure it makes sense. Everything's in the right spot. But this is something on the computer that you need to make sure is set correctly if you have the hardware in place, and that's PPS. All multi-beam systems, in my opinion, require PPS. You can run multi-beam without PPS, however, it's not going to be that accurate. You don't want to use a straight ZDA message for time tagging for multi-beam data. You want to use a pulse per second signal. So I'm going to use the PAUSE-MV as an example because that's one that we see the most of. The PAUSE-MV has a PPS output. So that is a pulse per second output. Other Trimble units, other GPS units have a PPS output. And that is a 1 second on, 1 second off pulse. And the way that, I'll show you what it's going to do, but I'll describe. It's an electronic on and off. So it's got the rising edge of the pulse on and the falling edge off. And that is precisely electronically 1 second of time. Okay? So if we mate that up with the ZDA message, which is UTC time, that's really made our time very accurate if we apply it. And that's what this is saying here. 1 Hz only, GGA at any rate, GGA or GGK. These are two common position messages. And then when a message arrives from your Echo Center, MRU, or other device, we get a time tag from the Veritime model that's been synced to the UTC PPS. Okay. This is just giving you an example of a ZDA and a GGA message. If anybody doesn't know kind of what this is, it's the ZDA, it's just the header, and then you've got, I think this is seconds after midnight, and then we have the hours, minutes, seconds, and then the year. This is a really old one, 2002. And then we have the GGA, which gives us information about time and latitude and longitude, number of satellites, the DOPS, the ellipsoid height, and some other information. So just basic NEMA messages. And then down here, you know, where's the time tag coming from? So ZDA from GPS, the Veritime clock model that runs in the background is going to be used. The GGA or GGK from GPS, you know, I'll show you, there's a button. You never want to turn this on. You never want to take timing from GGA or GGK. And then the Echo Sounder gyro, it's going to be taken from the Veritime model. So I don't want to confuse you too much about this. I'll show you where these buttons are in the software. Okay. So I talked a little bit about the PAUSE-MV having PPS. There are other devices that have a BNC cable that give us PPS. Okay. Some of the older Trimble models and some of the newer Trimble models have a BNC PPS connector that you can plug into a PPS box. And other people may make them. We make one as well. And what you do is you plug in the GPS serial cable into this PPS box, and the BNC that comes from the GPS that provides the pulse, and then our PPS box kind of aligns everything, and then out of the serial cable we get a good time synced ZDA GGA message for positioning. Okay, and this is just telling you the flow. So we got the GPS outputting RS-232 to the PPS, a 1 PPS from the BNC. It's powered by 12 volt, and then out comes out of RS-232 GGA, VTG, and ZDA with a PPS pulse on the CTS line of the 9-pin connector. Okay. I'm not sure what line that is. Does anybody know? Remember? So when you have a serial cable, a 9-pin serial cable, which connectors are used in the connector? 2, 3, and 5. 2 is transmit, 3 is receive, and 5 is the signal ground, unless you have a null modem. Yeah. So there's a CTS line that carries the pulse across that serial cable, so that we know how to measure the timing component from that serial connection. Okay. And in the GPS driver, there's a checkbox that looks for that CTS line to apply the PPS timing. Okay. And this is kind of what it looks like. So you just plug everything in, out to your data collection computer, and then you QC it, it just blinks red and green, on and off once a second. Okay. And this is used with the GPS DLL. In the survey program for the GPS DLL, you can graph the time synchronization. So you can see the ZDA versus the computer clock and how much they're drifting without PPS. But with PPS doing all the timing should not vary by, so this is not a very good screen capture, because down here is 10 milliseconds. And right about here looks about 5 milliseconds. So you're going to get less than a 4 or 5 millisecond delay for your timing with the PPS box. If there is a huge issue with timing, you're going to get an error message in survey. It'll say time sync, and it'll be red. So you stop your surveying at that point. Okay. Here's an option that is a little hard to find sometimes. In HYPACK hardware, you actually need to click up here on hardware, and you can get to the option, the device to sync the clock with. So if you're using GPS DLL or POSMV DLL, make sure you go in here and choose the right one that you want to sync with. This is also where you include the HYSWEEP drivers. Okay. Here's a little GPS checkbox for the PPS. If you're going to use a PPS box, use PPS and then graph the values in that graph that I showed you earlier. Okay, it's just some more tools that we have. This is actually not in survey. This is under the utilities menu under calibration. Okay. We already talked about where to put the MRU, kind of closest to the center of the boat as possible. You have all these slides. This lists the prices for the different MRUs and the resolution and some specifications if you're curious. And then we're going to move on to the differences in editing. The Single Beam Max program is very similar to MB Max. They're made around the same idea. Mike, our programmer, basically took MB Max 64 and just gutted all the multi-beam stuff and adapted it for single beam, and now the single beam is just like the multi-beam program and vice versa. You lose some of the tools with the single beam Max 64, but the look and the feel and the editing tools are very similar. The way that you apply post-processing positions is the same. They're in the same spot. The way that you look at the data and window or its 3D is the same. The profile windows are the same. So it's really easy to use. I'm just wondering when the old version is going to go away. Editing in HYSWEEP. The one thing that you get in HYSWEEP or MBMax 64 that you don't get in SBMax 64 is the point cloud. You don't get a point cloud in SBMax. So you can highlight an area here, you can hit the cloud pop-up, and now it's going to show you the cloud pop-up for that window that you've selected. Okay, so we've got plenty of time. Let's kind of push some buttons here. See if this one has a hardware configuration. Okay, so I want to show you the HYPACK hardware, how it kind of differs from single beam. And I want to build one out for you. Okay, so you have to come in here to hardware. Oh, has that been off the whole time? Okay, so in HYPACK hardware, I've just got a sample project opened here. Okay, and what I want to do is make sure that I include HYSWEEP survey. Right? Not a lot of people are installing Multibeam on a towfish, but what you want to do is add your standard positioning device under the boat. Okay, so under the boat, the two that I see more often than not are the GPS DLL. Okay, and this has the PPS box option, or you have the pause MV DLL perhaps. Does anybody have a coder device, an F180 or anything like that? You have an F180?
I rented one, I think, once.
Okay, and you use the F180 DLL as a positioning device. So if everybody's done single beam, they've used the GPS DLL. For folks that are using a pause MV or thinking about a pause MV, you know, it's a network connected positioning device. So it's got a PPS already built inside of it, but we don't connect a BNC or PPS directly to the computer. We use the time tags that are embedded inside of the Ethernet data that comes to HYPACK at the time. So from the pause MV, you split the PPS off to the Sonar and give the Sonar PPS, and then embedded inside of the Sonar packet is time to HYPACK, And then in the network data packet to HYPACK from the POSMV carries the time. So everything's on the same time frame. Okay? And for that to happen, for instance, for the POSMV DLL, you have to go into the setup and check this box right here. And what this tells the program is use the time tags that are embedded inside of the Ethernet datagrams and use that as the time source for positioning. Okay? So these are two basic drivers. And then down here, you have all the multi-beam sonar drivers. So right now I've got a simulation driver. I'm going to remove it. Anybody have an R2 Sonic? R2 Sonic Norbit? Okay. So those drivers are in this list. So the Norbit dual head. R2 Sonic down here. Resons. So you just add whatever driver you want, which you're using. So we'll add the 7125. Okay. Each one of these sonars has a set of options inside of their setup, depending on what you want to use. They're all different. So this one, for instance, do you want to use the datagram version 1 or 2? You know, these are questions that you can ask our tech support team, but by default we do a pretty good job to where you just add the driver, just connect it up to the right IP and port, and you're going to be able to start collecting data. Okay? There might be special considerations where it has a side scan option, or you want to collect snippets for use in geocoder. You can turn that on. If you want to log the 7K files, you can turn that on here. You can control the CBAT and so forth. You have a dual head, you specify the IP. So each one of these sonars has slightly different setup. R2 Sonic and Reson. Here we go. Are really popular ones that we have, but they have the ability to log the snippet data, and this R2 Sonic is able to log the true picks. If it's an option that you paid for, I think it's an optional stack that you can buy for that multi-beam sonar, or you can load the true picks, or you can log the water column data. Okay, so you need to talk to them to see if those options exist for your sonar. Okay. There's one important thing that I have to add about HYSWEEP hardware setup, and it's a little goofy in the way it works, but it has to be done this way, unfortunately, is we have up here the POSMV DLL, and this POSMV is giving me position, heading, speed, tide, water surface elevation, and heave, which is inclusive of pitch and roll. So it's giving me heading here. I still have to add heading to the HYSWEEP section. Okay? And depending on what kind of heading device, I'll just, nope, I'm using a POS, so I should use the POSMV one. A Planix POSMV network. Okay? And you'll connect it to your IP address into your port. And this is going to be heading for the multi-beam. And the reason you have to add heading twice here is because it's actually two separate programs for multi-beam. You're running the survey program and you're running HYSWEEP at the same time. And they talk to each other. Okay? But they don't talk to each other fast enough. So we have to add heading under the HYSWEEP section to eliminate the downsampling of the heading over to HYSWEEP, because heading is a really important component for what we're doing with multi-beam. I think, I'm just going to make this up, but it's close. If I was not to have this, and I just had heading coming in from the Planix POSMV up here, it would work. But it would only work up to 15 hertz. And I just made that number up, but it's pretty close. But the PAWS MV is capable of outputting heading at 25 or 50 hertz. So by adding it to this high sweep section down here, we're getting the full allotment of data that they're able to give us. So it's going to make your data more accurate with its heading. Okay? I know it's a little confusing, but this would be a basic multi-beam hardware configuration with device drivers. Okay?
Question. On your navigation, your GPS on Multibeam, if you're running RTK, do you have to have RTK for your heading and position, or can you do differentially corrected in RTK? Can it be split up, or do you have to make, when you're running one RTK, you have to run the other RTK? Say if you're using an R8 or an R6, an R10.
Right. So, okay, so one's giving you heading and one's giving you position. Is that the scenario that you run under?
No, I'm single beam. So,
okay.
I mean, and I have an R6.
Okay.
So, and I run RTK ties. So, but when you go to multi-beam, do you have to stick with RTK and RTK, or can you use differentially corrected also?
I'm going to give you the answer that I'd like to see you do. I'd like you to do everything RTK. Yeah. Just because there's too much margin of error on the seafloor.
Yeah.
When you start talking about all of the offsets, and then the differentially corrected heading or position that you're getting, that half a foot, so differential GPS is plus or minus a meter or two, right? But that's such a long lever arm going down to the seafloor, that 1 or 2 meters turns into 8 to 10 meters. Mm-hmm. It turns into this huge error on the seafloor. With RTK, it gets a lot tighter. So you're talking about a couple of centimeters turned into an error of 5 or 6 centimeters on the seafloor. So that's the difference.
Can you run one RTK for both with 2 antennas? If you can,
yep.
If you can go bring 2 antennas out of it.
Yep. You can. I forget what the number is, but you can have 20 GPS DLLs loaded and having all of the feeds coming into HYPACK and choose which one you want to use. Yep. Because in our processing software, once you're done collecting the data, you go into the editor, there's going to be a drop down to choose the device that you want to use for position, heading, and so forth. We do that all the time. You know, and what you also to further the answer to that, if you have, okay, so this is what happens on oil rigs and stuff offshore. To position those things, they'll put RTK GPS antennas on the 4 corners because they want to get the alignment just right so that they can anchor or spud down in place into the precise position. You want an elevation of all 4 corners as well. And if you're going to do that, you can add 4 RTK instances of GPS DLL. And over here you have this checkbox under the hardware, individual tides per mobile. And that will compute RTK for the 4 different devices and give you 4 separate water surface elevations, or RTK antenna heights. Okay. Let's see. Okay, is there any questions about the hardware program, kind of basically how to set it up?
One example you just were giving, so if you added 4 from that program, you have just 4 complete bolt setups, is that what it is? You can see all 4 on your screen at the same time? You wouldn't add all 4 under just one setup, right?
Great question. You can, okay, let me do it both ways and I'll show you what happens. Because it's going to matter to a certain extent. So I can add 4 here, okay? And I can also add extra boats and put those GPS under each boat. And this is the preferred way to do it. That way in the data display and for tracking for boat shapes, it works out better when they're all on separate mobiles. However, all the data is going to be collected and stored inside of the raw file. So when you go to process it, it's going to be really the same because everything works on a device ID. So under the options menu, I have show device ID, and this is how we differentiate one GPS from the next. Is we start at 0 for device number 1, and then we go all the way to device number 6 for the number of devices that we have. So,
on your top example though, if you had those two GPSs, if they were both tied to a transducer, would it show that on your display setting on the top one, or would it only just show, even though you got 4, it would only show if you're reflecting sound into a single beam? We had 2 single beams
right.
On the edge. It wouldn't show you both under your top example.
Well, it could. It could. In HYSWEEP, you can choose the device that you want to use. There's under the options menu in HYSWEEP, there's a device selection where you can drop down and choose what you want to use. It can only use one.
Under single beam, you'd have to set up the other mode to show both of them at the same time.
They would both show up if you added them under the boat. And the way you simulate that is add them both and give them both different offsets. And then you'll see them tracking separately with crosshairs.
I've never been able to do that.
Really?
That's why I thought you must have to set up.
Yeah, because remember that RTK water surface elevation isn't tied to your depths. It's only a correction for depth. So depth anywhere in HYPACK is a raw depth, and then the corrections get added later to give you a corrected depth. So if you start at raw depth and you add tide and you add draft and you add pitch and roll, you get to corrected depth. So that would just be a corrector. So I'd like to see how you had it set up before, if you had that checkbox under hardware, individual tides per mobile.
Yeah, well, the core main version of the Multibeam was to add a couple of transducers across the boat and use the one GPS and then do the others as offsets. And when you do your other transducers and fathometers as offsets.
Okay.
And under the top version where you add it all under one boat, it only would show you just the one transducer where the depths are coming from it. It wouldn't show you the offset transducers.
So even when you had offsets here,
Yep. Yeah, for each one.
it would only show the one?
I was told to do it was add a mobile device or add another boat and
Yep.
show them. And I still wasn't agree.
Okay.
Okay.
You would never catch me doing it this way, the top way. So maybe I'm too far removed from testing it this way. To give you an honest answer, I just set everything up on a mobile because, quite honestly, my thinking on this is each vessel has a function of position, and if position is unique, it needs to be added as a different boat, a different tracking point.
So that setup right there, would you have 3 crosshairs, 1, 2, 3, 4 crosshairs?
Yep, absolutely.
And that way, if each one of them had a transducer set up with it, then you would be showing those different depths. If they're 10 foot apart, you would see on your screen 10 foot apart, or data coming up on your screen.
Sounds like you got a Ross or something, multiple transducer.
Yeah.
Yeah. So I'm trying to figure out what you're. So are you trying to move the GPS to a transducer?
No, it doesn't show it. You can only show the one transducer. It'll only show one. I've tried setting it up differently. Maybe it's an error that I made. But they were able to separate the 4 separate boats and then have all 4 of the crosshairs showing up. So for example, if you had a 40-foot wide boat, you had them set up one crosser was 10 foot. In an ideal world, the display would show you 4 transducers collecting data going across and you're covering a 40-foot swath. You turn the 40-foot swath. It only ever shows just the one transducer.
And how many GPSs do you have?
Well, one GPS, but every one of them just have the offset from.
Okay,
that
so there.
GPS.
Okay, so I think we're approaching it the wrong way. Then I wouldn't use multiple instances of the GPS. I would have one GPS loaded under the boat, and I would use a generic offset driver.
Right, which you do when you set up. So this is where I jumped in. I should have probably confused it. So all those other boats.
Yep.
Can just have, and all you do is just give the offset for your transducer, not another GPS.
Right.
Each one of those boats would just have another fathometer transducer set up.
Right.
And they would just be offset. Because you're already collecting your data for the GPS in the first one.
Right. So in this case, I've taken this second mobile and I've replaced the GPS with a generic offset. And instead of entering the offsets where we normally do, I would give it an offset here relative to the position of the boat, and then that would put me a crosshair. Okay, so once you have the survey program, or the hardware program set up, you can go into the survey program. Okay. You can get to that HYSWEEP and survey from right here. Okay. Kind of move this stuff around. As you'll notice, I've got two programs running down here. I've got survey and HYSWEEP. And I can play back files. Under the file menu, I can play back these raw files that were collected. Make sure this is set up. Oh. Let's select the HSX. That'll be better. Okay. So you don't actually play back the raw files. The raw files are just like single beam files. If you're recording multi-beam data, there is a depth inside the raw file, but it's just a nadir depth. You'll want to play back these HSX files. So you have these arrangements of windows, like the beam pattern, this 3D seafloor, and they can all be accessed through the view menu. We have all these different menu items up here that can turn on. The real-time cloud doesn't work in this simulation. So just to kind of give you an idea of how, you know, some basic windows. So you've got the survey program over here where you're painting the matrix. Okay.
So in your profile window, if your sound velocity is not correct, can you see the frowny and smiley in the edge of your beams on the profile window while you're not just in your matrix?
Yeah, you see it in both.
I know you can see it in both. When you come back, you can tell if it's. But can you how do you adjust it while you're running while you're running the survey? Can you adjust it to get those beams back down straight?
Right, you can. Under corrections, you can add your sound velocity profile. So the first one you took, you load it in here before you started surveying, so it would flatten out the bottom.
Okay, so if you get to a place that you are not, the sound velocity changes dramatically where you start to see it, you would have the best way to do is stop the survey, go ahead and do your profile, then add it to there.
That's right.
Okay, so you want to try to keep the survey as genuine as possible, other than trying to do it at the very end. It makes your editing better, right? Am I correct? Or?
No. Because what you see here in the corrections are for display purposes only. So when you go into the editor, and let's just say your sound velocity was all screwed up the whole entire day, and all you saw was a big smile across your profile all day long. but you had somebody collecting sound velocity all day long for you, you could apply it and it would fix it in post-processing. You'd just be seeing the real-time stuff look goofy.
Okay, that's what I was asking.
Yeah,
about.
so it's for display purpose. Everything in HYPACK, survey, or HYSWEEP is for display purposes only.
So it doesn't matter if you do it while you're surveying or while you're processing, as long as it gets done.
That's right.
Okay.
Yep, as long as it's done. Yep. So, is there any questions? Got anything? Okay. Well, I'm going to stick around. If anybody's got any questions, I think we'll leave it at this.